Today we are going to discuss about Chapter 6, Lesson 4, Properties of Rhombuses, Rectangles and Squares. Main objectives of these lessons are use properties of sides and angles of rhombuses, rectangles and squares, and you will use the properties of diagonals of rhombuses, rectangles and squares. Main properties of special parallelograms. In this lesson we will learn three special types of parallelograms: rhombuses, rectangles and squares. See, a rhombus is a parallelogram with four congruent sides. A rectangle is a parallelogram with four right angles. A square is a parallelogram with four congruent sides and four right angles. Now let's check how Venn diagram shows the relationships. Each shape has the properties of every group that it belongs to. For instance, a square is a rectangle, a rhombus and parallelogram. So it has all of the properties of those shapes. Look at this. This Venn diagram shows the relationship. Rhombuses are like this, squares are in both cases. Look at this. Let's check the example 1, describing a special parallelogram. So decide whether the statement is always, or sometimes, or never true. So the first part, a rhombus is a rectangle, and second part, a parallelogram is a rectangle. Let's check this statements are always true, or sometimes true, or never true. Let's check it. See, first part, a rhombus is a rectangle. See, we can see the rhombuses, right? A statement is sometimes true. In the Venn diagram, the regions for rhombuses and rectangles overlap. So if the rhombus is a square, it is a rectangle. Okay. Let's check the second part. A parallelogram is a rectangle. The statement is sometimes true. Some parallelograms are rectangles. In the Venn diagram, you can see that some of the shapes in the parallelogram box are in the area for rectangles, but many aren't. Let's check the theorems in these lessons. First theorem states that if a parallelogram is a rhombus, then its diagonals are perpendicular. So look at this. If ABCD is a rhombus, then we can say AC is a diagonal and BD is also another diagonal. They will be perpendicular. See? That means these all angles will be 90 degrees. Okay, now let's check the next theorem. Theorem 614. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. Look at this figure. If ABCD is a rhombus, then angle 1, look at this, angle 1 congruent to angle 2. What they say? If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So angle 1 congruent to angle 2, and angle 3 congruent to angle 4, 5 congruent to angle 6, 7 congruent to angle 8. We are moving to the next theorem. If a parallelogram is a rectangle, then its diagonals are congruent. Look at this. ABCD is a rectangle, then AC congruent to BD. So mainly three theorems we discuss in this lesson. Well, now we are in example 2, using properties of special parallelograms. Here ABCD is a rectangle. What else do you know about ABCD? Let's check. Because ABCD is a rectangle, it has four right angles by definition. The definition also states that rectangles are parallelograms. So ABCD has all the properties of parallelogram. Which are they? Opposite sides are parallel and congruent. Opposite angles are congruent and consecutive angles are supplementary. That means this angle plus this angle will be 180 degrees, right? And diagonals bisect each other. These are the properties of parallelogram. Of course, this also will be applicable in the case of this rectangle. So take a note. A rectangle is defined as a parallelogram with four right angles. But any quadrilateral with four right angles is a rectangle, because any quadrilateral with four right angles is a parallelogram. So corollaries about special quadrilaterals are the following. Rhombus corollary. A quadrilateral is a rhombus if and only if it has four congruent sides. Rectangle corollary. A quadrilateral is a rectangle if and only if it has four right angles. Square corollary. A quadrilateral is a square if and only if it is a rhombus and a rectangle. So we can use this to prove that a quadrilateral is a rhombus, rectangle, or a square without proving first that the quadrilateral is a parallelogram. Now it's time to discuss example 3 using properties of rhombus. In the diagram at the right side, PQR is a rhombus. What is the value of y? That's we are going to check. So all four sides of rhombus are congruent. We know that, right? So the segment R is congruent to PS, right? R is congruent to PS. We know all sides are congruent. Okay, so we can write 5y minus equal to y plus 3. Equate the length of congruent sides. So you'll get 5y equal 2y plus 9 we'll take, and 3y equal 9. By simplifying, 9 over 3 will be y equal 3.